do we solve a system of linear equations using matrices and determinants? How do we solve for the values of x and y here? So one way is by solving them using one of the regular techniques we have seen, or we can use matrices to solve them. Yes, matrices. To solve the equations using matrices and determinants, we first need to write them in the matrix form. So we first write the matrix of the coefficients. For the first equation, the coefficients are 2 and -1. And for the second, the coefficients are 3 and 2. This is the matrix of coefficients of the two variables. And for this will be multiplied with the matrix which has the column of variables. The variables are x and y. So a matrix with the coefficients multiplied with a matrix with the column of variables. And this product is equal to a matrix with the column of the constants on the right hand side. That will be 4 and 13. This is the matrix form of the above system of equations. Why do we say that this is the matrix form? We will know why when we multiply these two matrices. Do you remember multiplication of matrices? To know if two matrices can be multiplied, we need to check their order. The order of this matrix is 2 by 2 and that of this one is 2 by 1. 2 rows 2 columns and 2 rows 1 column. As the second and the third numbers are the same, these matrices are compatible for multiplication. The order of the resulting matrix will be the first number by the fourth number. It will be 2 by 1. So we multiply the first row of this matrix with the first column of this matrix and write the product here. And then multiply the second row of this matrix with the first column of this matrix and write the product here. What will be the product of these two? It will be 2x minus y, and the product of these two will be 3x plus 2y. This is the product of these two matrices. And this matrix will be written as is. Now you see why this is the matrix form of the system of equations. As these two matrices are equal, we can say that 2x minus y will equal 4 and 3x plus 2y will equal 13. Same as these two equations. But let's come back to the important point. How does writing it in matrix form help us solve the equations? Let's see that on the right hand side. This can be written as A times x is equal to B. We have called this one matrix A and this matrix X and this matrix B. A times x is equal to B. What we're interested in is matrix X. That will give us the values of variables x and y. So to get x on the left hand side, we multiply both sides with A inverse. We get the left hand side as A inverse times AX and the right hand side as A inverse times B. Now A inverse times A will equal the identity matrix. We get this. And we know that the identity matrix times any matrix will give us that same matrix. So the left hand side will equal matrix X. And the right hand side will be A inverse times matrix B. That's how we get matrix X. We multiply A inverse with B. So when we are given the two equations, we write it in this form, find the inverse of this matrix and multiply it with this to get matrix X. And that will give us the values of the variables. We will solve this example in the next lesson. These were the two equations we looked at in the previous part of the lesson. We want to solve for the values of x and y using determinants and matrices. So we wrote this system of equations in the matrix form. Like this. We have three matrices here. We call them matrix A, matrix X and matrix B. A times x is equal to B. So if we multiply both sides with A inverse, we get x on the left hand side and A inverse times B on the right hand side. So what we need is x, as that will give us the values of x and y. We have B and we can find A inverse using the adjoint formula. Let's zoom out and find the value of A inverse. It will equal 1 over the determinant of A times the adjoint of A. And there was a condition which said that the determinant of A should not be equal to 0. So let's find the determinant of A first. It will equal 2 times 2 minus negative 1 multiplied by 3. That will equal 4 plus 3, which equals 7. As it's non-zero, the inverse of the matrix will exist. Now let's find the adjoint of A. Do you remember the shortcut to find the adjoint of a 2 by 2 matrix? Interchange these two and change the sign of these two elements. As these two are the same, interchanging them will also give us 2 and 2. Changing the sign of -1, we get 1. And changing the sign of this, we get -3. This is the adjoint of A. With these two, we get the inverse of A. Let's write it on the right-hand side. This is A inverse, 1 over the determinant times the adjoint of A. Don't solve for the A inverse immediately. Keep it as is. You'll soon know why. Now that we have A inverse, we come back to this formula. X is equal to A inverse times B. Matrix X is XY, A inverse is this, and matrix B is 4, 13. This is A inverse and this is matrix B. This will equal 1 over 7 multiplied by this product. How do we find this product of matrices? The order of this matrix is 2 by 2 and that of this matrix is 2 by 1. As the second and the third number are equal, they are compatible for multiplication. And the order of the resulting matrix will be first number by the fourth number. So the order of the resulting matrix will be 2 by 1. 2 rows and 1 column. The element in this position will equal 2 times 4 plus 1 times 13. That will equal 8 plus 13 or 21. What about the element in this position? It will be negative 3 times 4 plus 2 times 13. Negative 12 plus 26 will equal 14. Now we solve this by multiplying the scalar with each element. If we would have multiplied the scalar in this step, then this multiplication would have been very difficult because each element would have had the denominator 7. So we just wait for the final product and then multiply the scalar. What will this product be equal to? 1 over 7 times 21 will equal 3 and 1 over 7 times 14 will equal 2. That's it. We have got the matrix X. The variable X will be equal to 3 and the variable Y will be equal to 2. That's how we solve a system of linear equations using matrices. We write it in the matrix form, then we write X like this, then we find the A inverse multiplied with matrix B to get the variable values. In the next lesson, we will try to solve a system of 3 linear equations using matrices.